Welcome again to Wickerson Studios. That introduction's getting a little dry. Well, it's been about a month of making videos. I think I've made as many videos as I've found subscribers, so that's pretty exciting. Uh, I've been going pretty dry through the params, math, sets, vectors, and curves. I hope to make more slow down and make a lot more scripts as we go through the nodes of the surfaces and into what that means to meshes. And I'll probably go surfaces, intersections and transformations, then back to the meshes in the end. But let's finish us curves right now before my mind forgets how to operate all these things. The one we start with is pretty basic. I'm going to jump into here, and we're going to see that we have a curve that I built and actually referenced, so I could extract that parameter, and there it is as a line. You can make it recursive or not, but in doing so, you can see what happens. It breaks those, explodes those segments either yes, or no into the parts that it's gone into. So the vertices are the end vertices, and there they are. Or you can make it, I think it defaults to true, so you end up shattering, exploding that into all these other curves. Great thing to do. It doesn't really work on it only works on a polyline, so if I'm exploding, I believe, this shape, it might, I don't think so. Set one curve, and we're only exploding into, yeah, itself. Can't really do anything. So definitely it depends on that curve that I had there. If I take this one out, I should be able to extract that original one again. And there it is. So you can play with it, and I think it's good to set. And I'm going to start doing that on every node. Is whenever I use curves, I'm going to do that. Extending curves pretty cool. So we have this curve and this curve, which is actually an extend curve, a type of curve, which is, do you want a line, arc, or smooth ending? And you have to watch the subtleties of this. So if I actually take one and the other with a shift, you'll see that under a type 0, which will be line, then arc, then smooth, that's the same on the ends as we extend it. Sorry, didn't mean to do that. So as I play with the lengths being extended to start end lengths, that's going to affect both. And the types, if you watch, if I change the type on here, so if I go into this one, curve extend, one I'll leave at 0, the other one I'll take up to 2. And I think as we go in, you should be able to see as I take the extension out that it starts to deviate from one another. So it has this one's a major effect on what happened because of the curve. So you're basically changing the types, obviously straight, and actually there's even a subtlety in the curve. You can see that you can still see the difference on the tall one. They're both curving, but one is staying what's referred to as smooth versus an arc coming off of it. Okay, flip curve. I brought in, yeah, obviously these two curves. Now, what's interesting is you can have a guide to those curves. So if I extract those curves, and there's an interesting little rule here, which is kind of hard to follow. If the guide, and it's kind of interesting, if you read the, oops, didn't want to bake. If you read the guide here and read help, it's going to say if more than 50% of the base curve orientation is anti-parallel to the guide curve, the base curve will be flipped, and the flip action is set to true. If no guide is provided, then it's always flipped. So it's just something to know. So I've actually brought in this curve and another one. This one I brought in, but you can see I brought in a guide that was, if I extract it, this guide you can see is not perpendicular to that one. In a sense that this one kind of flows along, this one doesn't. So you get a true and false value for that. In the end, you end up getting these flip curves, and they do exactly that, flip over. The join curves is kind of nice. I just grabbed all these curves and I saw which ones would. And what I should do as I go through this is good practice is turn these off as I go. So this flip curve is going to take all these, join curve is going to take all these and actually join them into one curve. And that curve then becomes a selection of all those, as opposed to this being a bunch of separate curves. So it's pretty straightforward. There it was, and now they've become joined. Fillet is a nice little tool. Here it is, and you can see the effects of that. So on this curve, as I go into here, basically have a radius on this curve, and the radius is being altered at those points, at all those kind of kinky points that are on there. So you see the original curve. If I draw that out, you see the original curve, and you see this curve, and you see the effects on that. There it is. And actually, you see it just by clicking that node. This one I've reparameterized. I've actually set a parameter between 1 and 0, so it actually throws that curve in at whatever parameter along that line, and then it'll tell you the actual numbered parameter of where it's actually doing that fillet. So jump in here, grab this one here, and I hope I hit record. Yeah, all right. Yeah, there's the along the 0 to 1 parameter, T parameter. It's happening at 3.319, yada, yada, yada. All right, fillet distance is nice because you can actually direct it by the amount of distance you want. You can just set it to a number slider that comes off of that, and that'll happen at those kinks as well, wherever it can fillet. Offset surface is kind of nice, and watch the subtleties of this. Look at this little weird botchy thing that's happening here. Well, I've got it moving in the negative direction, and as it comes out, you can see it starts to buckle. It starts to have this little kink that occurs in it. The corners can be set here to none, smooth, round, sharp. So, and what was the last one? Chamfer. So chamfer is like a 4 chamfer, so that's just going to really make it a really tight corner as I bring it out. Hang on a second, I'll zoom back a bit. 4, there's 3, there's 2, there's 1. Maybe I need to bring it out a little farther just to make evidence of those differences. But either way, you're going to run into a little bit of trouble as you start to offset curves. Offset curve loose uses a distance instead. And as you see here, it's going up in the Z direction. I'm pretty sure it's going in the defaults. It just goes to the same plane. So there we go. I'm just bringing that one back off the other one. You can see a little effect of that. Let me try and go into top view as you see those two kind of reference each other and slide off of each other as well. Better go over the right front to show that happening. Here we go. There we go. Oops. Should stay on my right drawing. There we go. Bringing that one in and offsetting very nicely. So I think offset loose is a nice little tool as opposed to getting into this one, offset curve, but it depends when you want to use it. Pull curve is pretty awesome. I have a sphere, and this one's a little hard to see. I'm going to go in there as we rotate around, and I'm taking this curve right here, and that's the one that's been extracted. And that curve, actually this is the one that's been brought in, is going to go to that surface. It's going to go flush right to it. So if I take a look at both surfaces, it's really nice how it projects that up and onto that using the pull curve tool, which literally pulls the curve onto a surface. You can also try and do things with a project. I have a different curve here that's pretty ugly, and it's going to go and project onto that, and wherever it misses, it'll stay wherever it was a curve. And you can see how that has a pretty cool effect on how that gets pushed over onto that surface. I've been using those quite a bit. This one I put in red, not that I don't understand it completely, but I thought it was pretty interesting. This curve is a closed curve. I can close that curve first, and I did that. And I knew there'd be a seam in there somewhere, and this seam will move that seam. But I don't see any difference. So I went into pufferfish and had this really nice tool that was like, okay, start with a rectangle. And this was a nice example. So it's pulling that to, that was interesting. This curve actually wasn't the curve that it was supposed to, maybe it was this curve. I actually went from here and used an actual rectangle. This tool, which was seam to curve corner, and even though it appears to be a rectangle here, you actually see it working. That the seam is somewhere, and this one actually adjusts that point and brings it over right to the corner. And I would have expected to see that on this one, but I probably have to just make a different curve that has a seam that can be played with. This one, curve to polyline, is pretty nice. That curve to start, which was this one, I'll pull it out, pop it in there. Not that it has to be. Has a tolerance distance, tolerance to angle, and then it's min and max of what you're doing. So, and it'll tell you how many segments that actually happen in that. So I think if I go into here, and possibly I was playing off of another curve, min and max edges, curve, tolerance distance. Let's put in something big here and see how we can affect that in some way. Nothing. There we go. So yeah, the distance gets so short that you actually start to see how that will curve to polyline by having this effect. It would be better to put on a big jagged form, but it is a switch to 4, and then if I switched it to tighter numbers, let me see here. Apologize for the slowdown. Yeah, actually it's only going to read the 4, and it's going to read to the 3 points, and then I probably could get it to read to the 2. No. Yeah, 3 and 4 seem to be the ones working on there for tolerance distance. Play with the angles and play with that as well. Fit curve is one that I've taken a look at, and this curve has a very crimpy little kink that occurs in it. from not just that original curve here, if I start to play with different degrees on this fit curve, I start to get some really weird geometry that explodes off of this form. And the one notable is what happens at 8 or 9 degree. I start to get these really kinky little points that draft out, and my tolerance maybe is an odd thing that I put on there. But once again, fit curve is one that I've put in red because I'm kind of awkward trying to understand how to think how I would end up using that for different geometries. Anyway, jump back into rebuild curve. That's pretty nice. The first curve and the second curve, this one, if I start to rebuild that with a different count, you can see how you have major effects on smoothing and changing that. The same thing happens when you have a curve, a polyline. These are going to alternate between NURBS curves and polylines. You're going to basically have a curve that's your original and the one that you've changed, and you're doing this by tolerance on what it can be as you change how you want to affect that polyline. So even though we have this nice first one, pretty easy to see and understand, I can have a pretty major effect on that as I start to simplify that. And this will tell you exactly the reduction, how many lines were obliterated from it, and then reset. Simplified curve, same thing. This one only really is true or false down here on simplified, and it makes a curve that really is what it was into this very simplified curve. I'm trying to relate that simplifying curve to flattening and grafting data within the sets, thinking of tree items and what simplifying tree does. So I'm thinking, what does the simplify the curve do exactly? The last one is a smooth polyline, so you end up with something like, let's go into params. Oh, curves is a difficult animal to wrestle with and you get your head around totally. I don't know. Let me extract that polyline. See what we have. We have this same one that's here. So depending on the strength of how I want to affect that one, you can see I can really start to, you don't want to go too far out from minus or plus 2. You really have the ability to pull and warp that, and then you can also have how many times you want that to happen, so it gets smoother as you do it. And I guess this relates a little bit to the surfaces when you're playing with Weaverbird and your Catmull Clark, reducing meshes and adding those. But this is all in kind of a T parameter set that you're really only doing that to one dimension as opposed to two. So that could be a fun one to play with geometrically. But once again, this was a huge exercise in my mind just to get my head around trying to get in at least to all the nodes that I hadn't been doing. We are at the 12-minute mark. This was the full exercise to get everything up and running. I think I didn't internalize all my curves on my other ones, so if you do get this file off of GitHub and want to play around with it, you'll probably have to import some very simple curves in different situations. Some require polylines, some require smooth lines. But that said, have fun with it. I'm glad to be done curves, or at least looking at it and getting all these nodes up and running. And I'll just put the preview on. You see, it's quite a mess. You take a look at it. Oh, it's even slow file just to get everything up and running. Yeah, it's just a monster of a mess. Anyway, I know that video is probably not going to get too many likes. I've actually started to get my unlikes, which is okay. But if people are following, I'm going to try and hammer through this, keep it mixed up with some exercises that are kind of fun, and go into the nodes, starting with the primitives, which everybody should recognize, and what we can start doing with some scripts using the tools we've had all the way up to the surface tools. So hopefully I can activate these in all a very nice way, and some of these will become very familiar to people. The analysis included in the utilities and surfaces. All right, thanks again for watching.